My goal in the series of videos that this leads is to take a deep dive on this function on two variables and kind of get a summary of the kind of material you see in the first half of a chapter on surfaces, on functions on more than one variable. So in this video, we're just going to kind of get started talking about the domain range and describing some level curves of this function, f of x comma y is equal to 2x over x squared plus x plus y squared. I first encountered this particular function on two variables when a student came to my office hours with a question about their homework. It just happened to be a question in their homework involving a limit, and we'll see that in the next video, the actual problem that kind of preempted this. But I got curious about the particular limit question and just this function on two variables generally. So let's start off here talking about the domain. So it's a quotient. So I know the bottom of that fraction can't be 0. So I'm going to think about setting the bottom equal to 0 to find all the spots in the plane in the domain that, in the plane that can't be in the domain. And I look at this and I see the equation of a circle in its general form. So I want to be able to think about that more generally. So I'm going to write it in its standard form by completing the square. Look at that middle term, divide by 2, 1/2 squared is 1/4. So I'm going to add 1/4 to both sides of this equation. All right, and now I'm looking at the equation of this particular circle. So that is a circle centered at minus 1/2, 0 with a radius of 1/2. And those are values that are not in my domain. So my domain is everything except this circle. Every other point in the plane is in my domain. So let's see, if I'm going to write the domain down, this is a set of x comma y so that that bottom can't be 0. But I feel better about it having seen the domain as literally every point in the plane except for the ones on this red dotted circle. Noticeably, the origin is not in the domain. Well, I don't think we would ever have thought to plug 0, 0 in there, right? Get 0 on the bottom. And all of these other points are out of my domain as well. Next up, we're asked to think about the range, but since I'm working in the domain, I'm not going to let a set of instructions boss me around. I'm going to think about these level curves that live in the domain because there's a nice connection between level curves and the range. Anyway, level curves are curves in the domain where the function values, the z values here, are constant. So I want to imagine that I set my function here equal to some constant. And here I'm thinking about c being an element in the range, right? So I'm hoping by investigating these level curves, I'll learn a little bit about our range. So, all right, c is equal to this, 2x over x squared plus x plus y squared. Let's multiply everything on the bottom here over to the other side. Multiply both sides by that x squared plus x plus y squared. I said that as inefficiently as possible. All right. So I went on to distribute the c3. Let's go on and get this x over here. And what I see here is another equation of a circle in its general form. So let's see. I have a c times x squared. I could imagine factoring x out of this, and that would give me a c minus 2x. But since I factored a c out, that's going to be a c minus 2 over cx plus cy squared. All right, well, again, I'm thinking about this as a circle. I'm going to complete the square one more time and then think about what this equation, what this level curve is going to be in the plane. So let's see, I need to divide this middle term by 2, so that would give me a c minus 2 over 2c. I square that, and so c minus 2 all squared over 4c squared. I need to think about adding something to both sides so that this is still an equation. But I need to remember that everything in that set of parentheses is multiplied by c. So what I'll be adding over here is c minus 2 all squared over 4c. All right. do a little bit of light factoring, and I have c x plus c minus 2 over 2c all squared plus cy squared is equal to c minus 2 all squared over 4c. All right, well now I can easily divide out the c, and I guess I could have done that at the beginning, but now I'm looking at the equation of a circle. With a radius that's the square root of this and centered at 2 minus c over 2c, 0. All right, so what is that telling me? Well, that is telling me that all of my level curves are circles. Circles in the domain, except for maybe with one exception. We'll talk about that here in a minute. But let's see. There's some interesting values to think about in terms of what c can be. Right, and so kind of first off, when I'm thinking about c, I think thinking about what would happen if c were equal to 2 is going to be interesting, because that's where I'm going to get c minus 2 on top there to be 0, right? That's like trying to center myself at the origin. And then I think 0 is going to be interesting, because right now it doesn't look like c gets to be 0. And the reason I say that is because I'm dividing by c here and here. So if c gets to be 0, there has to be something else going on over here, and our level curve wouldn't be a circle. All right, well, let's just go on and talk about c equals 0. If I imagine this equation, 0 is equal to 2x over that denominator. Well, for a fraction to be equal to 0, just the top has to be equal to 0, and I get x is equal to 0. So anywhere x is equal to 0 will give me that particular value of c out. I just have to think about the denominator, which now I'll write all down, x squared plus x plus y squared. And all I need to know is that y is some non-zero value. Well, if I'm in the domain, right, that just means I'm on the y-axis. The origin is not in my domain. So if I'm staying in the domain where x is equal to 0, I'm all right. And so there's a level curve for c equals 0 that just runs along the y-axis. All right, so at c equals 0, I get a line, right? I get that y-axis. So that's at least a little bit interesting of a level curve there. Now let's talk about c is equal to 2. All right, so I'm going to think about c actually being equal to 2. So I can plug that value in. 2 equals 2x over x squared plus y squared. And we can do a little equation solving stuff where we multiply both sides by that denominator. 2x squared plus 2x plus y squared is equal to 2x. There's a 2x on both sides, so I get 2x squared plus 2y squared is equal to 0. Well, that would say x squared plus y squared is equal to 0, and the only point that would happen at is the origin, which is not in my domain. And if you just look at the original function, of course, we can't plug zeros in for everything. And so what I realize is that 2, not in my range. I'm never going to be able to get a 2 out of that function. All right, so level curve's aligned. There is no level curve at 2 because apparently that's not in my range. And now I just kind of want to figure out what's going on with these other level curves. So for right now, I want to imagine that c is in between 0 and 2. And I want to try to figure out what's going on with that particular circle. And I guess the easiest thing to think about here at first is just like a specific kind of test case that c is equal to 1. All right, so I can imagine plugging in a 1 to all of these c's. If c is equal to 1, I can think about the center of that circle. Let's see, 1 minus 2 is a minus 1 on top over 2. So my center is actually going to be a positive 1/2, x minus 1/2 there. And the radius of that circle, well, let's see, here I get that minus 1, but squared is 1 over 4. So I get a circle centered over here that's kind of small. So there's a level curve there. And if we think about the sign here, when I'm between 0 and 2, c minus 2 is going to be a positive number. But if I come out here, so let's see, the center is at a positive x coordinate. If I come out here and now c is larger than 2, like a 3 or a 4 or a 5, I plug that value in there and I'm just going to see x plus some constant, my center is going to be at a negative x value. All right, so let's think about that c is equal to 3. All right, so if c is equal to 3, let's see, my center is going to be at 1/6, or better said, at minus 1/6. And then the radius at 3, let's see, on top, I'm going to get a 1 on the, it's very small, and centered over here. So 1/6 and then a very small circle inside the red circle that's not in my domain. That just gives me one little place to kind of think about. Let's just say, let's c equal -1. Always a good choice to use plus and minus ones. All right, well, at the top of this fraction now, it's going to be a -3, but divided by -2 plus 3/2. I'm still going to be on this side. But now what I observe, that gives me a 3 on top of this, so 3 squared is 9 over 4. And so I'm still on this side. I'm centered at 1.5, and I have a bigger radius. So in this region, for the values of c, I get level curves that are tiny circles. In the middle, I get circles over here, and then I get bigger circles over here, and right there I get a line. And so I think my map of level curves are a bunch of circles with one line, and of course with that missing. But along the way, I discovered the range. The domain written here, and then the range, well, it's all of my real numbers. I just have to leave out 2. Because I didn't get a level curve when I tried to plug 2 in there. All right, we've explored this function a little bit. We've talked about its domain, range, and those level curves. I do have a computer-generated image of the level curves to check out here. And we'll see other computer-generated images. But on this side, right, that's where we see these values of c. There's so many level curves in there, right, that they're like you can't see the difference between them. That's these in this region. And then finally, the c's that are less than 0 are the big circles out here. And now the question kind of to pose as we end this first video is, what does this function look like? We have a contour map of it. We have a topographic map of it. But what does that mean this function is going to look like? And that's a good thing to think about as we go into that next video.